See, today we are going to see about encoder decoders. Before going to that, we have to see about multiplexers. Multiplexer. What do you mean by multiplexer? Meaning to one. See, suppose a person, a manager is there in a company, and there are some 10 employees in that company out there, and you know there will be an operator or telephone operator. There will be a system, you have heard about EPBS. Okay. In that, suppose one of the employees want to talk to the manager. He will ask the operator to connect to the manager. Suppose employee 2 wants, he can be connected. Employee 5 wants, he can be connected. One at a time. Anyone. Anyone can talk to the manager. So many employees are there, but they are going to connect to the manager. So many to one. It's called multiplexing. But one at a time. Which will be controlled by the operator, telephone operator. Who must talk? He must decide. Suppose employee 1 asks him to connect, but he connects number 2 means he only can talk. Even though 1 asked him, suppose the control is wrong, it will never bother. It will be connected to the employee 2. Okay. So who must come out, or what is the output that must come? Who must talk to the manager? That is called a multiplexing. Out of many, it is going to connect to one among the persons is going to be connected to the manager. Okay, many to one. Quite reverse is called a demultiplexing. Quite reverse. The opposite of this is called a demultiplexing. What is it? Suppose the manager wants to talk to one of his employees. Okay, 1 to me. He can talk to any of these 10 employees. Okay, he can ask the operator to connect to number 5 or number 6, number 10, whoever he wants. This is called multiplexing and demultiplexing. Why we are studying this? Because in the next semester you will be studying about microprocessor. In that microprocessor we have address bus, data bus. Address bus, data bus. Just a small introduction I want to give. Address is, suppose we are residing at some house. We have an address for that house. That is the address. Who is inside? Myself. I am the data. So somebody must fetch the data because I am the data, but where to go, that is checked by the address. Likewise, we have 16 lines for address. 10111100001111 something. That is called the address. And the data, this is 16 bits. So 16 lines will be there, or 16 wires will be there for giving the address. That wire, one of the wires is 5 volt, it is taken as 1. Another wire which is 0.5 volt or 1 volt even, that will be taken as 0. Very less voltage, that will be taken as 0. So that will be identified as zeros and ones, and it will give the proper address. And from in that address, if it goes, the microprocessor will see which data is there. Then what has been done with the data, then will be the process. What you have to take or subtract or add, whatever it is. What to do with the data? Data is important. Address, where is the data? That is the address. See, in microprocessor, what they are doing now, because the data is 8 lines. So 16 plus 8, how much? 24 wires are required. For the address 16 lines and for the data 8 lines. So they are minimizing the lines by doing this multiplexing, because what they do know, the same 16 lines used for address, and among that 16 lines they will take 8 of the lines and use it for the data. Confusion அதுக்கு கரெக்டா வந்து என்ன பண்ணோம், முதல்ல வர அட்ரஸை எடுத்துக்கோ, அடுத்து வர 8 வந்து டேட்டா எடுத்துக்கோ. அதுதான் வந்து மல்டிப்ளெக்சிங், மாற்றி மாற்றி அது வந்து இது கனெக்ட் பண்ணும்போது இது அட்ரஸ் ஆகிடும், data. So in the program we are studying about multiplexing here. And there's a little developed one encoder decoder. I don't say you not have heard about these words because decoder encoder you all words. Sorry, we will just see this multiplexer. Multiplexer, the basic 2 to 1. See these two are the input lines. Say for example employee 1, employee 2 and this is the output. This is the output, this is the manager. Who must be connected to the manager? That is decided by this S0 line. This is the control. How? This can be either a 0 or a 1. It is a 0 or a 1. If this is 0, this will be connected to this. What does this have? I0, I1. What does that have? It may be a 0 or 1, that's all. That is the information. It may be a 0 or a 1. What is that? We don't know. So, if it is 0, it will come here. If it is 1, it will come here, that's all. The person is talking, whatever he wants to talk, he will talk to the manager. Right? So now, if I give a 0, this will be connected to output. If I give a 1, this will be connected to the output. Now if you see the circuit diagram, you can easily learn. See, there are two AND gates and a NOT gate and an OR gate. So, if I have say I0, I1, if I give a 0 here, what will happen now? The 0 goes here. The 0 goes here. Whatever the I1 may be, we did not bother because this AND gate will be off. One of the inputs is 0, the output of an AND gate is 0. If any one of the inputs is 0, output is 0. So, if this is 0, I am giving 0 here, therefore this comes here, therefore this AND gate will never work. It will be off state. What will happen to this one? So this will go to the NOT gate, it will be inverted as 1. This 1 is coming here. If this is 1, it will be 1. Already this is 1 here. If this is 0, 0, 1, I will be getting 0. That means whatever is here, I will be getting. So, 0 will be coming out and whatever comes here, it will be coming out as output. Now here, if you put 1, this will be 1, this will be 0, so this AND gate will be off. Therefore, whatever is here in I1 will come out through the OR gate to Y. Understand? This is AND OR network. It can be replaced by a NAND network. Now the control line is only one single line. Since there are two inputs, if the control lines are 2, how many inputs can be there? If the control lines are 3, how many input lines can be there? 8. 2 power that number. If there are 4 control lines, or I shall say in other words, 4 control lines are required for connecting 16 people to a person. Understand? 0, 0, 0, 0 to 1, 1, 1. And how I can decide it? You put 2 power that number. I have 4 control lines, 2 power 4 is 16. I have 5 control lines, 2 power 5 is 32, like that. So it is decided by that number, that is n. N is 2 power n. Next, I develop this to next state, that is 4 to 1. 4 to 1, you just see here, and then we have the control lines S0 and S1. If you have 0, 0, I0 will be connected to Y, 0, 1, I1, 0, 1, 0, I2, and 1, 1 is I3. 1, I1, I3 is connected. So like that. So if you see here, you just see I0, I1, I2, I3. All these 4 are connected, and there is an extra input here. You just see it, See here, there is an extra input called enable. What is that enable? Always you have come across this one. Enable means it is just like a switch. Just like a switch. See, now I am switching on my fan. Switching on my fan. Whether the current is there or not, it will be non-state. Okay, that's different. If I switch it off, the fan goes off. If switch it on, the fan goes there. The fan is on, it is running. Okay. But the current is there, very much sultry. We want fan, but if that switch is off, nothing can happen. Nothing can happen. Only when the switch is on, only when the switch is on, then if the current is there, the fan will run. If the current is not there, the fan will not. You take it as 0 and 1. Only when I switch it on, when the current is there, it will be running. When the current is not there, it will not be running. This is 0, that is 1. Current is there, 1. It will be, fan will be on. Current is not there, 0. But only when I switch it on. Only when I switch it on. If I don't switch that on, irrespective of whether the current is there or not, it will not run. Understand? Likewise, if you see here, enabled, all the AND gates are connected to this enable. You see? All the AND gates are connected. Suppose I make this enable 0. If I make this enable 0, whatever may be I1, I2, I3, I0, whatever it is, it will not function because all the AND gates are 0. All the AND gates are 0, irrespective of I0, I1, I2, I3. When the enable is 1, that is the switch. When the enable is 1, it will be working. Quite reverse is also possible. Sometimes, we always think about on and off. There is one thing called the reverse, that is negative logic. Have you heard of it? Negative logic. See, we always say 0 means off, 1 is on. This is not normal. Okay. There is another thing is there, negative logic. If 0, it is called on. 1, it is called off. I can have in the other way also. Sometimes when the enable is 0, it will function. When the enable is 1, it will not function. Understand? அதாவது சுவிட்ச் ஆஃப் ஆகிருக்கும் தான் ஃபேன் ஓடும். நம்மளுக்கு வந்து ரிவர்ஸ் ஆகும். அதாவது நெகட்டிவ் லாஜிக்னு பேர் இருக்குது. சுவிட்ச் ஆஃப்ல இருந்தால் தான் ஓடும், ஆன்ல இருந்தால் ஓடாது. இது மாதிரி சில அக்கேஷன்ஸில் நீங்கள் வந்துருப்பீங்க. அப்போ அது எக்ஸாம்பிள்ஸ்லாம் நம்ம தேடி பார்த்துட்டு போகலாம். யூ கேன் ஐடென்டிஃபை சச் திங்ஸ். ஓகே, சரி. இப்போ வந்து இதில் வந்து பார்த்தீங்கன்னு சொன்னால், see all these things 0 பாருங்க, அதனால் இதில் பாருங்க, இது கனெக்ட் பண்ணிக்கலாம், இது கனெக்ட் பண்ணிக்கலாம். பிகாஸ் இது வந்து S1, இது வந்து S1 பார், இது S0, S0 பார். இது என்ன கனெக்ட் பண்ணிருக்கேன்? S1 பாரையும் S0 பாரையும் கனெக்ட் பண்ணிருக்கேன். அதெல்லாம் வந்து 0 0 0 0 கனெக்ட் பண்ணுறது எப்படி போடுறோம்? S0 பார், S1 பார். அடுத்தது இங்கே பார்த்தீங்கன்னா இதில் வந்து S1 பார் கனெக்ட் ஆகிருக்கு, இது S0 கனெக்ட் ஆகிருக்கு. ஸோ 0 1 0 1, அப்புறம் 1 0 1 1. That is connected. Suppose நான் ஒன்று மட்டும் சொல்கிறேன், உங்களுக்கு தெரிஞ்சிடும். என்ன enables 1. இப்போ வந்து என்ன என்னாச்சு? enable 1 சுவிட்ச் ஆன்ல இருக்கு. இப்போ என்ன பண்ணணும்? Suppose this is 1 and you see 0 0 னா பாருங்க, இது வந்து இப்போ இது வந்து 1 ஆயிடுச்சா? S1 பார் 1 ஆயிடுச்சா? அப்புறம் இதுவும் 0, S1 ம் S0 0. அப்போ S1 பாரும் S0 பாரும் 1 1 ஆயிடுச்சா? அப்போ எல்லாமே 1, enable 1, இதுவும் 1, இதுவும் 1. எதை எதிர்பார்த்துருக்குது? ஒன்லி I0 உடைய இதுதான் எதிர்பார்க்குது. I0 0 ஆயிடுச்சுன்னா இங்கே அவுட்புட் 0 வந்துடும், ஃபைனல் அவுட்புட் 0 ஆயிடும். இந்த I0 1 ஆயிருந்தா அந்த 1 1. ஸோ தட் வில் கம் அவுட் as அவுட்புட் I0. ஸோ 0 1க்கு I1, 0 2க்கு சாரி 0 1 0க்கு I2, 1 1க்கு I3. This is what is called a 4-to-1 multiplexer. இதில் தான் பாருங்க, இந்த enable போட்டு கொடுத்துருக்கேன் பாருங்க. If this enable is 0, if this enable is 0, irrespective of 0, S0 and S1, output will be 0. Output will be 0. But the function only when the enable is 1. Only when the enable is 1, 0, 0, 0, 1, 1, 0, 1. Accordingly, I0, I1, I2, I3. So, if you have 8 to 1, so this is the multiplexer.